Hello students, in this video we are going to see about IPv6 header. In this slide you can see the side-by-side comparison of IPv4 header and IPv6 header so that easily you can understand the difference between IPv4 header and IPv6 header. What is the main reason of going from IPv4 to v6? Yes, it is IP address scarcity. If I take the case of IPv4, it was designed under in the year 1981. So when they are designing the IPv4 protocol, the internet designers they didn't assume, they didn't visualize this much growth in internet, and so many computing devices will be participating in internet. So IPv4 was 1980s design. Considering that scenario, they have designed the IPv4 header. Later in 1990s, it becomes very clearly visible that the IP address scarcity, the number of IP addresses are not sufficient to connect the systems. So they started introducing the concepts like private addressing. Then they went for CIDR, classless interdomain routing. To support this private addressing, they have introduced the NAT protocol, network address translation, which converts the private address into the public address. But all these substantial efforts are doesn't meet the goal. So by the mid of 1990s, they started designing the new IP header called IPv6. But before IPv6, they had IPv5, which is very limited applications. Specifically for the audio, video, real-time communication, they tested IPv5, but it is not a successful one. So they went for the next version, IPv6. Let's look at the packet structure. So in both the IPv4 and IPv6, the first field is version. In IPv4, the version number will be 4. The value 4 will be represented as binary bit here. In the same way, here we'll be having the value 6, since it is IP version 6 as a binary number, 4-bit binary number, number 6 will be represented. And in IPv4, the next field is HL, header length. We have to specify the header length in IPv4. Why? Because the header length is variable in IPv4. The minimum length of IPv4 header is 20 bytes and the maximum size is 60 bytes. And in any packets, it can be within this number. Some packets it can be 24, 30 bytes, 35 bytes, 36 bytes. So it varies from packet to packet. So in each packet, we have to specify the header length. So we are having the separate field. Okay. So it is a 4-bit field. Suppose if we are having the value 12. Okay, we are having the value 12 means again this 12 should be multiplied with the number 4. The value you are getting 48. So this IP header length is 48 bytes. So whatever values you are having in this header length, it should be multiplied with the 4 as a rule to find the total length of the IPv4. So the minimum value should be 5 here. When you are multiplying 5 with the 4, you are getting the value 20 bytes. So 20 bytes is the minimum IP header length. So the minimum value should be 5 and maximum value can be 15. So you can check 15 into 4, 60 bytes. So we can specify the maximum length of the IP. Comes to IPv6, there is no such field. The reason is we made it as a constant. The IP header length in the case of IPv4 addressing is 40 bytes. It is fixed. It does not vary from 20 to 60 like IPv4. It becomes a constant value 40 bytes in the case of IPv6. IPv6 header. So no need of specifying it through the field. We are not having the HL field header length because all the packets, all the IPv6 header are 40 bytes in length. So we are not having the separate field. But instead of that, we are having the traffic class, which is nothing but equivalent of type of service we are having in IPv4. Okay. I'm putting an arrow mark to explain. The type of service field is represented more or less with some changes represented as traffic class in IPv6 header. So the traffic class will represent the priority of the packet, which packet should be given what priority level, high priority level, medium level or low priority. All these things will be specified in the traffic class. Accordingly, the router will take the decision to route the packet. Then we are having one new field in IPv6 which is not in IPv4 called flow label. Flow label is nothing but basically it is a number. The flow number may be any number. Uh, Let me take the flow number will be 12,000. It can be anything. The flow number is given for the sequence of packets from the same source to destination. The packets from a source to destination will have the same flow label. So this flow label represents how the packet should be handled by the intermediate routers. If you're taking the characteristics of the packet, all the packets will be having the all the packets which are having the same flow label will be from the same source, and the destination same destination for all the packets, and all the packets may be having the same priority level. Then all the packets may be going through the same route, and all the packets should be given the same quality of service. So this flow label defines how a packet should be handled, how the sequence of packets should be handled by the intermediate routers. So that's the purpose of flow label. Technically, if you are looking, IP protocol is a connectionless protocol. Connectionless protocol in the sense uh, each and every packet is given the act as a different entity. But if you are giving the flow label, we are giving a particular flow, a particular characteristics to the flow of packet. Okay, so we are trying to make it as a connection oriented protocol by having the flow label field. Comes to the next one. In IPv4, we are having the identification field. So the purpose of identification field. In IPv4, we are having the fragmentation principle. The packet, when it is in travel from source to destination, based on the MTU size, it may be further fragmented in the intermediate routers. So the packet which is fragmented into two or three fragments should have the same identification number, which informs the receiver that these fragments belongs to the same packet from the source. For that, we are using the identification number, which is not in IPv6 header. IPv6 does not allow fragmentation in the intermediate router. The source system itself will fragment the packets. So no intermediate router is having the rights to fragment the packet. So they have removed the identification field. And since they have removed the fragmentation in the basic header, we are not having the fields like identification, flag, fragmentation in IPv6 header. Instead of that, we are having the payload length. The payload length represents the total length of the uh, IP datagram. The total length of the IP datagram is 65,535. So this can be the maximum number. IP packet can be 65,535 bytes. But in reality, it's not possible. There is no transmission medium which carries this much data, okay, commercially used. So we have to fragment the data, but fragmentation happens at the source system itself. Then, like the options field we are having in the IPv4, here we are having the next header. This next header field is supporting the fragmentation and other options field that we are going to see in the separate video. Then here we are having the hop limit. And the hop limit. Hop limit is nothing but TTL field here, time to live. Okay. TTL field, how many routers a packet can cross. If you have mentioned a TTL as 20, a packet is considered as live packet till it crosses 20 routers. After 20th router, the TTL value becomes 0. The packet is considered as dead. Similarly, we are having the same thing as hop limit. Actually, this is the right word. Okay, instead of time to live, hop limit. If hop limit is 20, the packet can travel up to 20 routers. After that, it becomes a dead one. And here we are having the upper layer protocol field in IPv4, okay, which is not in IPv6, because always the upper layer is the TCP UDP, and since it does not require to be explicitly represent, they have removed in IPv6. Then the source address in IPv4 is 4 byte in length, that is 32 bits, the length of IPv4. In the case of IPv6, the source address is 16 bytes, translates to 128-bit length. So like IPv4, we are having the source address field, but the length is 128-bit. But here we have mentioned 0 to 31. So it will be taking 4 sections. Okay, all the 4 sections will be the source address. The next 16 bytes, the next 16 bytes will be the destination address. 128 bits. Again, it will be having 4 subsections. The next field is next header. It's not mandatory that we should have the next header. If you want to include any useful option in the IPv6 packet, we can add the next header. Otherwise, we can attach the data following the basic header. So this basic header length is 40 bytes in IPv6, whereas it is variable in IPv4. The basic header, if I'm using the basic header, it is 20 bytes in IPv4 and it can be maximum up to 60 bytes, but here it is fixed at 40 bytes. Okay. Thank you.